Hi, thank you, Aina. Thank you, Olive. Thanks for having me in the first place. That was a great sharing session before. Thanks to all the panelists previously. So I'm Rachel from Raw Robotics, and my company is a mobile robot startup. We do mostly on industrial potion. What we have on a demo sharing session is for 3D simulation and conferencing. If I can have the video on. 5, 10, 20 years ago, I never could have imagined that one day I'll be talking about real-time 3D meetings to an audience that I can't see. Recently, my life has been changed, or had been. It's a 3-day-a-week kind of work days. It's yesterday, today, or tomorrow. And minimal real-life conversation is just so different. Hello there. I'm Rachel from Raw Robotics. If you have heard of Industry 4.0, digital transformation, IoT, then spend me 15 minutes of your time and I will show you how to conduct real-time 3D engineering project meetings globally without leaving your desk and have the hairstyle of your choice any time of the day. Our demonstration of 3D simulation and conference are powered by visual component and stage. I mentioned that I'm from Raw Robotics. But who is Raw Robotics, right? Raw Robotics is a startup company and we have offices in Malaysia and Thailand. We are the official reseller of visual component and stage for Malaysia, Singapore and Thailand. For clarity purpose, Visual Component and Stage are two different platforms. Visual Component is a 3D simulation technology company from Finland, and their simulation solutions are trusted by hundreds of organizations worldwide to support critical planning and decision-making process. Stage by VR-On is an innovative German company that develops in the areas of virtual reality and real-time 3D conferencing. It is what we'll be doing and showing you later. This will be the key to connect you with a secure real-time 3D conferencing service to discuss important engineering data with global project partners. My challenges are addressed to manufacturing automation or in general automation process for all industries. One of the key concerns for most of the stakeholders that I spoke to has always asked me this: how do I know it's the right decision to automate this process? Now we all know that there have not always been a one-stop station to get all answers. It has proven to be even more challenging during COVID-19 crisis that's happening with the global lockdown, strict protocols and procedures on entry and exit of any places, even more so on countries. Stakeholders, vendors, suppliers, partners were not able to hold meetings like they normally do. No site visits, no survey, no game plan, just flat 2D drawings and 3D models being bounced around in emails and some conference call. What if there is a way to bridge this gap, where layout planning and design can be iterated live in the meeting when everyone is in the meeting like you would do face-to-face? What if the tools required is intuitive with minimal expertise needed? What if the proof of concept are now possible to show? What if you see exactly what you needed to see to make the right decision before your next major investment? If those are some of the questions that you have said yes to, then stay on and let's see what the possibilities are with these two platforms that I'm about to show you. Key to make the 3D simulation realistic is to have a big network and is constantly being updated. Visual Component has everything that you need to build the future factory that you imagine. And everything that you see here on the pictures are just some of what you will be able to see. But it has, a picture says 1,000 words. You can pretty much have everything here with just one singular platform. Let's move on to the actual fun part. Before we move on, I just want to say that this is a pre-recorded demo. So if you have any question, please leave us a message in the chat box and we will try to answer later on when we have the time, and then answer as many as possible. Back to the demonstration. In most automation project planning, we start with understanding of what they need, what they want to achieve before we come up with a solution proposal. And normally it's in a lot of email trails, 2D simulation, 2D layout, or a lot of conference call to understand each other well. Why not do it in a 3D environment that you will be able to see it exactly as it is? It helps, right? In this demo, we really want to show you the value of the digital tools that we are introducing that will improve your project across board in your organization and to the important stakeholders. It can be system integrators, Industry 4.0 allocators, automation partners, or you can be a manufacturer or an intralogistic partner, be it EMS, OEM, or supply chain. You will find these tools essential in your organization by the end of this demonstration. Here right now, we have been simulating a simple process line that includes human operator. We have seen a CNC machine, conveyors, robot arms for pick and place and palletizing, human operators on stations, and mobile robot for transfer, safety fence, and just now we were converting some 3D generic object for our production purposes. What you really see right now is us trying to lay out the process modeling to see from the production from stage 1 all the way to the transfer stage. It took an hour to do the layout, to map everything out, and then probably another 40 minutes to an hour to do the processes using preset parameters without customization. Now, I'm not saying customization is not possible. It is possible when requested to mirror actual production. For time purposes, we're doing a preset version. You see all the lines? It's to tell the robot what direction or what is the manner that it should be done. And this we have to emulate out. Once we have all this, all we need to do is click the simulation button. And we are even putting safety fence right now for each area. And then we speed up the simulation so you can see it as whole. You can do it in a time span of a few days, a month or so. So as it simulates, you can see how each stations are working on their own task. When the pallet is full, when the products are being delivered, the AGV is picking it up to move to the destination that it's supposed to be. And then QA and QC, human operators are checking the products before sending it to the buffer and packing station. And then if we zoom in right now, we will be looking at the palletizing part where the pallet is full and then it's being sent to packing. If you think that's all a simulation can do, you're forgetting an important part of simulation, where it's capturing the statistic report. What we are going to show in a little bit is that VC is actually equipped with the ability to provide statistic report on production for each machine and components. You can see how your pick and place robot are being used, or palletizers are being used, to study whether is it worth the investment. If it's being utilized in full, sure, why not? Which means our return of investment will be fast. We are also looking into the study of our resources, like mobile robot, human operators. Do we need more than 3 operators or do we need less? and it can also be shown that way. And as to the extent of the layout design, we can export it as technical drawings, which is what we are going to do right now. We're going to export it into this A3 technical drawing, which means you don't have to cross over to another platform to export this. You can do all this within this one platform itself. All the machines and components are actual size, which means everything that we put in here, if we say that it fits into your layout, it will fit into your layout. With that, we are also able to generate your technical list. What is what, the name, how many quantities are there. All these things will help you see things clearer. What are involved, right? If you think that is just everything that we can do, since we are into 3D, we are also able to do 3D PDF drawings. And then there will be images, videos that we can export out and can play over and over again. And of course, as I was saying, statistics are actually used to do production planning, optimization, and studies. What you see here is actually a normal image. And right now, we are seeing a 4K image resolution. It can be used in PowerPoint or your website. Everything that you want to do to get your stakeholder to understand the impact of this automation process is. To host a 3D conference, you have to understand one rule. Conference hosts up to 12 people at one time. So all you need to do is send the invite and voila. As guests, you need to do is accept and download the client app. As simple as that, you don't need anything else. But of course, we need to know whether are you a guest or are you a professional user. Professional user who allows you to make tweaking in the 3D environment that you're working in. But as guests, all you need to do is do the walk around yourself. It will be very, very nice if you have the VR goggles, because then you would actually be able to walk into the environment as though you are there in person. So these are the main menus. At any time of during the session, you can take pictures using the camera function. You can measure the distance of all this machine, how big is it, how long is the conveyor, and there's the slicing tool where you can see what is happening inside the machine. Once everyone is ready, as host, you can give them a walkthrough, or they can just walk to any part of the 3D layout as they want without following the host at all. Inside this virtual reality environment, you can pretty much do everything from looking at it from different angles, top down, do whatever you want, as you would on site. But what we are trying to show right now is that we were able to do live iteration. That is important because the moment you have a disagreement and you think that it's better in certain ways, we will be able to do that. So what we are saying is that we don't have that much space, and then we need to move the location of the transfer closer. And this is exactly what we are doing. We move the endpoint and it will be reflected immediately on the 3D environment that you are in. So what you're seeing now is a close-up of how you walk into every different section of the 3D environment. And then if you think it's lacking of something, like one of the guests, he was saying that he thinks maybe having an extra shelf would be better. And this is exactly what they're doing. We're going to put another shelf there just to show how it works. It could be, maybe after we put in, we realize it's actually too close to the operators and it will be a safety hazard. Because you don't really know, you think it would fit, but might or might not, right? And then sometimes you just realize like, hey, I don't want this robot models. I actually want a different brand because I heard it works better, or I think it fits into the environment better, or maybe because it's part of the company policy. We can also do that. See, we're gonna change the robot immediately and have it and show you. You're like, yeah, I don't think it works, or maybe it works. Drag and drop. That's it, and it just works. So what you're seeing right now is a slicing tool. In a real demo, I think we'll be able to show you better because as you walk in, we'll be able to give you that even more live view of how it's working here. On the fast forward, you might or might not see the thing properly. If you look at it right now, this is a measurement tool. It will show you how long the actual conveyor belt is. And for hosts or guests or whoever it is that are in this environment, take as much picture as you can, as you want. We can do all this in this session here right now. So if we have all this, then you'll be able to understand that why this tool would help you eliminate a lot of miscommunication. Consider digital tools as a means to solve automation problem. I've identified 4 phases of automation project. We started with phase 1 on identification, then modeling, testing, and implementation. While we cannot do much on phase 1 and phase 4, but what we can do is a lot of things on phase 2 and 3, where it's the most time consuming. We can do all this and improving our solutions, our automation projections without stopping the actual production on site itself. And all this are being done using visual component and stage. Everything that I've shared so far shows that the benefit is just immense, and it is essential in our current day. It was able to do through layout planning. All our components in e-catalogs are according to an actual size. You were able to study your production and optimization. You will be able to understand if your resources are being utilized in full or if your production are actually being maximized. You can do all that there. You are able to do accurate robot simulation without stopping the production, and that is amazing. Imagine stopping a day of a production line and how much it would cost you, right? Improved stakeholder buy-in is a must because people always tell you that a picture says 1,000 words. If it does that, imagine what a video or virtual reality model does to you. The simulation will tell you everything you need to know whether this is the right type of investment or not. It just explains itself. You don't have to do anything any further. More importantly, the price structure is simple with no hidden fees or add-ons. You pay for what you get. That's it. End of story. You are able to create proof of concept or digital twinning, as they call it, in a more fancy manner. A representation of physical assets at low maintenance, zero risk of safety and damages. If you build that before you build the actual proof of concept to show anyone, imagine the amount of time and cost that you would save. And it is as real as it can be. This is my cue. I will have to end this here, but before I leave, I would like you to stay for another 2 minutes to look at our latest collaboration with university. It is no secret that today 3D simulation and virtual reality is the up and coming trend and increasingly essential tool for the industrial professionals to put application together for a real or physical robot without relying upon the genuine machine and subsequently decreasing expenses and time being spent. Raw Robotics aims to continue developing this market within the industry together with the academias. In order to meet the demand, we are working with university to train simulation engineers for the future, create talent pool and know-how with young engineers. We are very honored to work with UTM as our first local market collaborator in this. What you are seeing here is some of the projects and assignments being done in one of the courses by Associate Professor Dr. Yong. And we had a lot of fun time together with just 4 hours of crash course. Everything was developed. I will put in a lot more samples, but due to time constraint, these are the only videos that I'm able to upload and show you. So what we wanted to do is to get feedback on how it would work even in education environment, and the feedback has been really positive because now they're able to pretty much make anything that they design and simulate it as though they are in an industrial manufacturing environment. With that, they're able to see the challenges that a real life layout planning and design will work, as well as production optimization as well. It has been such a joyful time together. Thank you, class. And this is my cue. I will have to end my sharing here right now. Stay on. If you still have time after this, please feel free to join our live panel session that's happening at 3:30. Talk soon. Bye. Hi, I hope that was informative. Because of time constraint, the demonstration has been cut from probably a good 40 minutes to a 15 minutes video. A lot of things were a little bit blur, but if you have any question, we are happy to take anything that you want to know on 3D simulation or even the conferencing part. While we are waiting for more questions from the audience, I think a general introduction of a more comprehensive introduction of visual components stage and how UTM were partnering with Raw Robotics for this in one of the courses would be interesting as a background. So visual component has started this 3D simulation softwares, I think back in the early 2000s, am I right? So they have been there throughout the entire industrial manufacturing process and slowly moving forward, and they add on a lot more things, especially in terms of their e-catalog. It has been one of the bigger ones that I've ever worked with. Yeah, 2,400 components altogether in an e-catalog is pretty impressive, I have to say. And then after that, we have Andre from VR On, an innovative company based in Germany. Andrea has been in the communication industry for a very long time. That's what I remember, right? And he has always been the one that are like doing the innovative communication portion. And recently, VR has been the trend. I mean, VR has been the trend for the past 5-10 years, but never as prominent as right now. Purely because with pandemic going on, everyone is staying home. There are actually more time to work on all these digital tools. And then, of course, it's a lot more affordable now in comparison to like 5-10 years ago in terms of all the virtual reality equipment or the requirement needed. And our recent collaboration with UTM has been a success. And I mean a real success. The class actually consists of 44 students in total. And the only thing that Raw Robotics was actually doing in UTM was we took 4 hours in one of the session, in two of the classes, because per class was 2 hours. We gave them a crash course of how to operate visual component, how to build their 3D simulations. They need to have basic understanding of where's what is process modeling, and what kind of modeling they can do, and then how to get it work. And then we send them tips and tricks, and that's it. The rest of the semester has been they themselves completely on the fly. Yes. We are 7 minutes away to our panel session. I think we should just continue. So we cannot agree that it has been quite a ride, right, since last year for manufacturing, or as a matter of fact for most other industry out there. Everything changed. The entire scenario changed, and not just manufacturing. It's just that manufacturing has a bigger impact because they actually required more physical work out there, right? We all had to change in a heartbeat to accommodate COVID-19 workplace protocols, procedures, and of course the global lockdown with the current travel restriction has disrupted many things that are in place. Before pre-pandemic, we were so happy about how globalization has made everything easier. And today, the disruption forced many industries to escalate the digital adoption by 3 to 5 years. In one of the survey, it was saying that it actually advanced the industry by at least 7 years. This is an important topic in times of uncertainty. So we are honored to create this panel to share the key industry trends in the industry and how it impacts the education system. We will also be answering the question that you have about adoption of digital tools. So as your moderator, I'll be guiding us through this process. We have a short period of time, so we are going to break this into two very distinctive sections. The first one will be one of the trending questions from our organizer, Iskandar Investment Berhad, and other commonly industry addressed topics. We have sorted through them and we'll be addressing them as many as we can during this panel. So we will start there. And the second section will be an open Q&A section where we'll take in live questions and we will do it as it goes. So a little bit about myself. I'm from Raw Robotics. I'm a co-founder of Raw Robotics, and Raw Robotics is a startup based in Malaysia. We actually have offices in Thailand as well. And our second office in Malaysia will be in Iskandar. So I would like to formally welcome everyone here today, either with me now or behind the screen sipping your Milo or coffee. Welcome to Ignite 2021. Today we are honored to have our panelists from various parts of the world. First of all, we have Mustafa from Visual Component, a 3D simulation company software from Finland. If I can have Mustafa on the screen.
Hello, everyone.
Hi, Mustafa, welcome. And then further away, we have someone from Germany, Andre of We Are On, a real-time 3D conference company. Hi, Andre.
Hi, Rachel. Hi, everyone. I hope you can hear me.
Welcome.
Hello, Andre.
And someone closer to our home, Professor Atif, a director of Cairo of UTM, and Cairo stands for Center of Artificial Intelligence and Robotics. Welcome, Professor Atif.
Hi, Rachel. How are you, Mustafa and Andre, and all viewers?
Good. Thank you for coming to this session. It's a precious time. It's very hard to slot this panel session in because we have such a huge time difference between us and those in Europe. And I'm so glad Andrea is no longer in US and back in Germany because the time difference is even worse if you're in US. Yes. So today we're going to be talking about manufacturing strategies, right? Adoption into digital strategies. There are a lot of things happening. As I said earlier, the industry has actually escalated close to 7 years because of the forced adoption of digital strategy when everything have to close down and everyone have to work from home right now. It has never been a big issue because we can always just go to office and all our equipments are in the office, right? has always been like that. The house, you only have like that one small corner where you, instead of putting a laptop or opening it, you probably just put your bag there. Because we would do most of the thing in the office and try not to bring work home because we value work-life balance. Yes. Um, for the entire day, for the previous few panel sessions, we have been hearing a lot about how IFR, International Federation of Robotics, shows a global average robot density of 113 robots for every 10,000 employees. In Asia itself, with Singapore and Republic of Korea taking the lead, they are looking at 118 robots for every 10,000 employees. Whereas in Malaysia, we are on a lower robot density. We are only at 55, even though recently government has launched a IR 4.0 roadmap and framework. So previous panelists has shared many of their opinions of the roles that have to be played by governments and private sector. It ranges from grants, infrastructure, upskilling to even education, right down to education in secondary and tertiary education itself. So my question, and I would start with Professor Atif, as the final panel session of the day, right? I would like to ask, what is the main role of public sector in this IR 4.0 effort, and how can private sector also assist in that effort? Professor Atif?
Okay, thank you very much, Rachel, and hi to all, and also for our distinguished panelists, Mustafa and Andre, from the different part of world. I'm Atif from Cairo, Center for Artificial Intelligence and Robotics, not Cairo, Egypt. So don't misunderstand. Okay, so we put ourselves under Cairo UTM. So when you Google Cairo and UTM, then you can find us in the website. About the question by Rachel just now, the roles that we are playing as the academic entity, or Cairo is a center of excellence under UTM, and we are now trying our best to facilitate in terms of developing talents. So Cairo ourselves is a center that aims to be a leading center in AI and robotics for the good of mankind. And here we try to develop some of the frontier intelligence system for industries and promote and disseminate knowledge, as well as to communicate some of our products to the society. And we are very proud to see how the collaborations between industries, academia, and also other entities such as agencies to be hand in hand to assist in terms of how to help the nation in increasing the robot density issues that was highlighted by Rachel just now. And in Cairo, we already have some projects that have been initiated, and what was highlighted by Rachel just now in terms of applying some of these virtual components where we try to utilize this kind of technology in our classes. And hopefully we see that this is part of the way that we can try to enhance the usage of some of these tools to provide the gap during this pandemic situation. So I believe that talent development is one key for us to be a good nation to prosper in the area of robotics, and also the collaboration work between all these entities that was highlighted earlier. Okay, over back to you, Rachel. Rachel, sorry, you are muted.
Yes, so thank you for that. So I agree with Professor Atif. Talent development is definitely a topic that has been ongoing, and it has been ongoing since I think the beginning of time, right? I mean, talent is something that doesn't just happen overnight, and it doesn't just come just that way. Once a while, you get people like Albert Einstein and stuff that does amazing things, but not every day. The rest of the time, we actually have to develop them. And something closer to the industry, Mustafa, you have been working directly with automation area, I think, for the past close to a decade and a half and more, right? What are your take on this? What do you think the main role of a government versus a private sector should be?
So let's take it like one by one. So first, let's go over what the government can do. So in my eyes, the government is usually like the facilitator for adoption of new technologies. So their role is enablement. So this is, of course, like my view on it. So what the government can do is like provide financial incentives for companies to adopt robotics and automation technologies. And it can be, for example, things like subsidies, financing options, and also tax incentives. So those kind of things. But that's just like one avenue of it. The other part is like what you guys have just mentioned is like also the educational component to this. So what that means is that like improving like the training and the upskill areas. So the first part, if you consider training, I would say is like including more robotics and automation courses in university level programs like bachelor's and master's degrees. And the second part, which is then the upskilling part, would be then applied to adult education centers. So what that means is like engineers that have already been working in the industry, if they want to upskill themselves and learn about new technologies that are now coming into play because of Industry 4.0, then they have some place to go so that they can learn about the new stuff. So if you look at the second part then, which is like the private sector. So most of the time, like investments are driven by two things. The first one being either it results in cost saving for the company, or the second one being that like there's revenue generation increases. So either like the costs go down or their sales numbers go up. So I think like robotics can actually help in both things. So they can take over some of the redundant tasks, for example, like palletizing processes, just like the rinse and repeat kind of things. And they can do also like precision things more better than a human can. For example, if you're talking about robotic painting, and if you want to have like a fine layer of coat which has even thickness on a surface, then robots are the champions there. Then of course there's things, for example, like they can work for more than just like the normal shift hours, which is 7 to 8 hours. So there's like lots of benefits to incorporating robotics. So the thing is that I think this mostly comes down then to the system integrators to be able to communicate the value properly to the manufacturers that are going to be implementing their solutions in their facilities. So what this means is that like system integrators should actually be able to communicate the value in financial terms, to be able to portray things like, for example, what would be the return of investment if a manufacturer is looking to implement a specific robot into their facility.
That's an interesting take of things. So I understand that robotics in Malaysia has been a tax-free thing for the past 10, 20 years, if I remember this correctly, and it is still in place. Initially, I think it did develop a certain traction on automation adoption on the earlier days when they first started it. I think recently it has just kind of dropped, and it has to do a little bit with a lot of manufacturing moving locations as well. So, but it's good. I think the tax incentive is something that is definitely worth looking into, and we have been going on the whole day about this topic, right? And a lot of them are a lot on grants, but tax incentive is definitely something that's good. Thank you, Mustafa.
Thank you, Rachel.
Andre, so with you, you have been working in the communication section, and I think you have been around the world as well, like Mustafa and Professor Atif have been working across the world with different robotics automation projects. What are your takes on this? I mean, you have seen different governments on automations and how private sector should work. On to you.
Yeah, thank you, Rachel. Yeah, indeed. I think I'm maybe not so much an expert on the robotics area, but I think on the communication industry in principle. And I think what I've seen in my experience is that government and regulations around new technologies and liberalization of enablement is a key element. And I've seen that across my entire career, basically. The more active the the more active the government is to basically incentivize, as Mustafa said, but as well liberalize the application of new technologies, the more successful the private sector in those countries can be. So I can only encourage as well thinking about how can we encourage and liberalize the aspects of automation. And I think at least from a European perspective, there's a lot of labor laws and things like that that play a role as well, not only the technology itself, but how does it embed into the overall manufacturing and labor structure of a country, because of course it has a big impact on how things get done in the future. And then from the private sector, I think it's a global world, right? And I think it's very important for companies to understand where I am in the global competition, and what are the best practices from any type of company that I might compete with globally. And that's changing very fast, specifically now with the digitalization. So maybe I think one thing the private sector need to think of, what is our competitive advantage being in Malaysia? Why, I mean, is there a specific reason why we are behind the adoption? Or, I mean, why don't we take maybe use of some of the advantages that robotics provide, and other countries or other players in private field in other countries have already adopted? So really like global benchmarking, and what can we really learn, and how can we make our location here in Malaysia more competitive? So I think that's basically at least a couple of observations that I can bring to the discussion.
Thank you, Andre. That's good. So if I understand you properly, correctly, Alice, I think a set of panelists with the industrial and the academics opinions should group together and set a certain benchmark of how robotic automation in Malaysia should be in order to escalate this. Am I right? Yeah, I think that would be good. So like I said earlier, the pandemic causes a huge rift in many industry, and it's not just automation, but our lifestyle in general has been disrupted. But it's even more prominent in manufacturing, because the disruption actually forced many stakeholders to rethink what production optimization means under uncertainty. Because we have heard of flexible manufacturing for a long time, and it has been a keyword for a while. It was trending for a long time, right? But what is flexible manufacturing if you're unable to see exactly how you can ramp up and ramp down? So the common question that every time we talk to anyone as a robotic company was, when it comes to IR 4.0, production downtime during planning, layout design, on-site survey, deviation from overseas suppliers, partners, integrators, and so forth, actually put a longer duration of time. But when it comes to flexible manufacturing, we're talking about like instantaneously you have to just go. Otherwise, you will miss the timeline for you to ramp up or ramp down. So this topic has been a concern. I guess back to Mustafa. What do you think are the key factors to ensure automation application being applied efficiently while addressing, the concern of having to shut down the factory for you to do surveys and everything? Because you have worked with a lot of industry players in that sense. What are your take on this one?
So yeah, so to start with, I would say that it is quite well understood what would happen like if there's production downtime, so there's losses. So that's pretty well understood among like everyone that's let's say like working on implementing an automation project. On the other hand of things, like I think the point that I would really like to focus on is then like how communication can play such a big role when you're deep diving into these automation projects, as because there's lots of stakeholders. So when there's more stakeholders, communication then becomes key to kind of ensure the success of a project. So in the past, like what has been done is that like if there's, let's say like you want to automate a process in the manufacturing side, the old school way would have been to use like 2D drawings. DWG files would be exchanged between the stakeholders. There would be like even cardboard models would be utilized. There would be other things, for example, utilizing 3D static models, CAD models, or just simply writing like and explaining what the project would be in words. But now that in Industry 4.0, like the technologies that are kind of coming up and shining, like for example, I bring up, of course, my own company now, like Visual Components. So what simulation brings to the table is many key things here. So you can bring together like the CAD, you can bring together like the flow in the factory, you can bring together like the kinematic information for a robot. So all of this, when you bring it together, you can start checking for many things already, like before like the project has even begun. So these can be things like, for example, the reachability of the robot, checking for spatial issues like where the robot is actually supposed to fit, and also then all doing things like, for example, checking for collisions. So it can then like lead down to other things, for example, checking for the lead time, the cycle time. So these are very important things like that every manufacturer is interested in knowing. So instead of just using words, what you can do is like you can develop a digital replica. And this digital replica is the means of communication. So you do not have to exchange words and nothing is really lost in translation. Everything is in front of you and everything like mathematical figures that are extracted from the simulation in terms of like I was saying, like what would be the throughput of the entire system once you have replaced, let's say like 2 humans and now the task is being done by 1 robot. So is the throughput requirement being met or is it not? So, and of course, these are things that are done like even before the project has even begun. So let's say like you later find out like maybe the throughput requirements were not met. So what is to be done now? So maybe like you need a faster robot, so you change the robot model now. So this can help in avoiding some very costly mistakes later on down the road. Let's say like right now, no money has been invested, no work has been commenced, so nothing really has been done. So just by implementing newer technologies and improving communication, you can do so much. So I think identifying a problem early on can help reduce the overall problems that would be caused by like, let's say like a very costly mistake by finding out like it later on down the road. So my key takeaway would be that communication plays a prime role.
Thank you, Mustafa. When we talk about communication, I cannot stop but think about Andre because he is like so in this zone, right? So I understand that when you started Stage and telling us about Stage on the real-time 3D conferencing and how virtual reality is actually live for all engineers right now, and we are not just talking about robotics automation, right? I understand that Stage are also capable of helping in architectures and all the other things that you can put in 3D, it should fit into Stage platform itself. So while you're working on this, what do you think are the key factors that this whole communication portion would help in the automation sector? Andre?
Yeah, of course, communication. I love it. Yeah, I do it for so many years. Interesting. I mean, it's all about communication. And as Mustafa said, I mean, I think a picture says more than 1,000 words, right? And I think that's the principle. And I think that goes for 3D even more, right? Because, I mean, if you look at production systems, production facilities, it's very complex systems, it's very complex processes, and they get even more complicated. And in order to really get all stakeholders aligned around what needs to be done, communication and understanding it in 3D and the details of, say, the moving parts and the processes and are very important. And that's why we as well focus with Stage on improving the communication around 3D models in principle, because we feel when we started that there is a big gap what you can do with tools like Zoom that we use today and 3D models. We took a look at the gaming industry, and I think it's interesting that 2.8 billion people in the world do online gaming today. So there is a lot of people that already immersed, at least in the private space, and basically understand what it means to be in a 3D model, kind of navigating in a 3D world and grasping that world much better than if they only would look at the picture. So, and that's basically the concept about 3D communication, really being in the model and being in the model together, right? And then being in the model represented by avatars, so we can interact basically with the model, and everybody can see it from its angle. We can talk to each other, we can point at things, we can measure things, we can see the simulations. And what we noticed is, as you mentioned, Rachel, with COVID, a lot of things have changed, and suddenly the demand for getting experts and stakeholders together without being physically in the same space has been even more critical, actually. Before COVID, we saw adoption in very international environments where a lot of experts needed to come together and fly around the world in order to for project meetings and in order to discuss complex projects. But with COVID, we see even that a lot of people work in home offices. In a lot of countries, it's even mandatory to work in home office. So there needs to be efficient solutions in order to improve communication. And I mean, in a 3D model, being in the 3D environment, it's just, I mean, providing so much benefit to the overall process, and with that, to the overall efficiency, and with that, in the end, to the reduction of downtime, and because you have less failures produced during that project. So yeah, that's certainly our learning here in the last 2 years.
All right, that's good to know. So what you're saying is that this entire environment being able to do that is actually the key connector. Am I right? I mean, yes, we have a simulation, we have a video that would be able to simulate everything and show you exactly how automation would work. But without being able to be there in person, sometimes you just cannot look at it from that perspective. And what real-time or virtual reality provide is actually enabling you to be able to do that without being there in person. It's still a roundtable discussion in many contexts. It's just now we are doing it virtually like we are now. I mean, to be honest, like 15 years ago when I first started my career and stuff, I would have never imagined I would do a panel session virtually like this without looking at the audience. Moving forward, so now we understand the industry concerns and how it can be addressed, right? So we on the previous session, the panelists were talking a lot about education and how engineering itself is a course that requires a lot of hands-on, right? A lot of practical, a lot of hands-on. Otherwise, you just don't get the actual engineering look and feel of it, and it's just very hard to proceed with the course as well. So, and this spread across board and not just on tertiary education, but as well as even Montessori, kindergarten, primary and secondary education as well. So there's definitely been an unease in education, especially in engineering, right? Professor Atif, what do you think are the biggest challenge for you and your team in UTM on providing course virtually to your students during lockdown? In our last experience with one of your course was that I noticed that I have students joining into the session from Turkey, from Indonesia. We are talking about like people that are more spread out than where we are right now. I mean, I have people from Finland, Germany, Malaysia, and my colleagues from Thailand joining in. But this is way bigger than that, and you have 44 students in a class. How do you handle that?
Yeah, thank you very much, Rachel. So I think it is very important for us to currently understand the situation. And I keep on reminding the students that we are in the current situation where everyone is struggling, the teachers are struggling, the lecturers are struggling, and also and we understood that the students are also struggling even more. And I think one of the main challenges is the communication, which it's more specific on the internet communication, because some of the students may have challenges where they have limited access to internet. So when we don't have access to internet, then all the methods that we use for online learning and online teaching will be disrupted. So one of the way that earlier when we are talking about the management in the university is on how to think of providing both the hybrid way of online learning with together the face-to-face learning. But due to the pandemic situation, which is up and down, so then the university decided that we go fully online. So the lecturers also have to take the, some of the actual planning on how to implement the teaching as best as they can. So we have been provided some courses on how to arrange the classes. So in UTM, we have this UTM e-learning, where the student can access all the files that we upload, and we have Webex or we have Google Meet to conduct our classes. But again, as what Rachel was highlighting, that most of the engineering stuff is more towards hands-on, feeling on and feel and touch of the items, and component is very, very important for them to learn. And this is some of the limitation that we have at the moment. And we try to replace as best as possible with some of the virtual kind of thing. So last semester I was teaching the first year students on introduction to engineering. And normally for each semester we have tour or visits to actual companies or maybe factories. But last semester I have to make a virtual tour. So I gave them the link for certain, and sometimes we even ask some of our engineers, for example, Dr. Yong from DF Automation. So he prepared a special video for, the students to come in, just like what they can be in their actual living visit. Okay, so this is one of the way that we try to see on how to replace the actual thing together with the virtual thing. And secondly, I think that the assessment is also part of the challenge, where once we delivered the materials on how we want to assess the students, whether they can grasp the understanding of the materials in the class. And one of the way that I think that we have discussed earlier is on how the materials should be able to be delivered within a different kind of approach. So for example, in one of the class that was conducted I think this semester, last semester by Dr. Yong on his class on robot technology for automation together with Raw Robotics and also the visual component. I think as what you have mentioned, having more than 30, 40 students in the class and manage them in virtual is very, very challenging. But I believe that this is the way that we have to use some of the current available tools to provide the look and feel, okay, of the available components. So we cannot go and visit the real factories, but then we're using the components that was being loaned to us. So we are able to provide the students with this kind of environment, and they are very happy with the tools that was provided, and hopefully students can manage and gain more knowledge in this kind of experience. And to wrap up the point that I would like to highlight here, that these are some of the challenges that everyone is trying to adapt with, and we have to be agile, we have to be perseverance, and also to put a very good grit for us to move forward. And this is what we also put together in the National Robotic Roadmap. So in the first question, one of the question, by Rachel was on how the academia was trying to do, on how industry was trying to do. And we're trying to map this together in the Malaysian National Robotic Roadmap, an initiative that was organized by MOSTI, and currently ASM is managing it together. I'm one of the sub leader in R&D, and we are trying to get more inputs from stakeholders, industry, academia, agencies, all together in listening and how we want to plan towards the betterment of the industry in Malaysia.
Thank you, Professor Atif. It is true that engineering require a lot of hands-on and the motor skills. So when you cannot actually hold the thing and actually put a screw on it, it's just different,
Yeah.
right? But all these measures that you have took in education, and I think out of the many universities that I'm looking at, I think UTM actually was able to provide a very good virtual platform to continue the education system. So all these measure actually enables capacity for, building further e-learning as well as resilient and readiness for recovery at any time for the education system, which is very good. But once we are there talking about this talent education, right? You cannot miss one of the things is that talent development is a big challenge. I mean, everything is online right now. I know I have family friends that will be asking like, oh, my kids are doing e-learning. They have no actual social skill. What am I supposed to do right now? Everyone is worried about that. And when it comes to robotic and automation industry, it's even more so because as the post-pandemic are recovering in many parts of the world, many industries are actually definitely headed towards more and more digital adoption, which is why we have this panelist, right? It is escalating and it's definitely not showing a signs of slowing down. I guess back to Andre, in your opinion, what would be the skill set that engineers today and future will need to have to work with the digitalization strategies? Something simple.
Very simple, yeah. I mean, first of all, engineers should still be very hands-on on the hardware, right? Because you should never lose that part. But I think being really fluent in all digital aspects is very important. And I think I've seen that, say, here, for example, in Germany, in some of the curriculums, working in virtual environment and co-working and creating in virtual environments is already part of first kind of curriculums. And I think this virtualization of all aspects of design, of manufacturing, is just something that every student needs to know and basically being able to cope with on a daily basis. I think that's super important.
All right. Thank you, Andre. Mustafa, what's your opinion in this one? What are the key skill set engineers should have today for the future?
So I would say like some of the things, for example, of course, like since we're talking about robotics and automation, would be like being able to program robots for actual industrial tasks like palletizing, depalletizing, machine tending, welding, painting, things like that. Then also being able to use different kind of like softwares, for example, like to do offline programming and virtual commissioning. So I think these are upcoming fields and have a lot of interest in them.
Thank you. I just got my cue. I think we are close to the end of our time together. It was shorter than what was told. We have questions, but I think we will be answering it. If you can just contact either of us, we will be able to answer it on the networking platform. But before I close this particular session, right? With all the panelists from across the world, which is very hard to get by. If there's one thing that you would like the audience today to take away from this session, what would it be? Professor Atif, maybe we can start with you.
Yeah, I mean, from me, I think normally what I ask my student is to hold these three things. A for attitude, S for skills, K for knowledge. So ASK is ask. So if you don't know, please ask and try to put yourself together with this good attitude, higher in skills, and better knowledge. Thank you very much.
Thank you, Professor Atif. Yes, definitely always ask, right? Andre, would you like to give your takeaway today?
Yeah, I think as we learned today, communication is key. It will remain key, and be open and drive new ways of communication to just don't stop improving communication.
Yes, communication is definitely the key. If there's people, there's definitely communication, and you actually cannot skip that no matter where you go, virtual or physical. Thank you, Andre. Mustafa?
So from my side, like I think the key takeaway here would be that Industry 4.0 technologies can lead to big savings in the long run for most companies. So don't sleep on them.
That's a great one. That's a great one. So I hope everyone got some great ideas. I actually had fun with this panel session, and I think we worked really well together. Thank you to the organizer and the host of IIB for having us. If we did not manage to answer a question, as I said earlier, we'll be happy to do it on the networking platform. And I think right now I'll hand it back over to the MC for the quiz session. Thank you.
Thank you,
Bye.
guys.
Thank you.
Bye bye.
Thank you very much. Okay.